Adding and subtracting rational expressions. We're going to first talk about when we have a common denominator, then we'll move into where we don't. We have to do a little manipulation, but today we're just going to do some interactions. A couple of things we want to emphasize. Adding and subtracting rational expressions. It's going to have a lot of similarities to adding and subtracting normal fractions. Remember, when we're adding or subtracting a fraction, you have to first have a common denominator. And once we have that common denominator, if I'm adding 2/3 and 1/3, that common denominator, when adding and subtracting, we never change the denominator. It just stays the same, stays to 3 in this case. When we don't have a common denominator, that's what we'll get into very soon, we have to first get a common denominator. Once we have the common denominator, then we can, again, combine the tops. These aren't going to be exactly like fractions, but you're going to see a lot of similarities. Another thing we've got in this section that we have not seen is exclusions on the restrictions on the domain. Because when we are dividing by a number, if we have a variable in the bottom, we now have some limitations because we cannot divide by 0. Since we cannot divide by 0, we have to limit our domain or restrict our domain from becoming 0. Now, some of these examples we won't have that opportunity because we have multiple variables, and this is just because we're simplifying. But we will still mention it each step of the way. Kind of like this one. We don't have, A and B, neither could be 0 because that would make our denominator 0, but that's not what we're looking at here. We're talking about simplifying. Okay, the main step, anytime you're dealing with any kind of a fraction, rational expression, whatever the case may be, and a rational expression, what that is, very simply, is when you have a division and there is a variable in the denominator. So this is a rational expression. When we are dealing with a rational expression, we need to keep in mind, one, like we talked about restrictions on the domain, we have multiple variables here, so that does not apply. And then secondly, we've got to have a common denominator. Well, all day today I'm going to give you a common denominator. So with that we have a little less to worry about. But remember this, when you have the denominator, a common mistake is people want to call that 24, or they want to call it 12a squared b squared. It's not the same. Just think about, what would a fraction do? Well, like the 1/3 and 2/3, that equals 3/3. Same thing here. It is 12ba. Now, if you reverse the letters, that would also be fine, but the whole point is the denominator does not change. Now in the numerator, we can shove all of this together now because they have a common denominator. But the most common, we're going to do a lot of subtraction today, because if you can do subtraction, you can do addition. And like I just showed there, if I try to circle these and try putting them together, I missed a very important part, and that is the fact that this is subtraction. So I want to encourage you, anytime you have this, just like when we had the radical terms and we were about to square or square root, we immediately come over to the side to the right of the negative sign and put parentheses. And hopefully that parentheses will remind us that this negative sign will be distributed to each of these terms. You are allowed to skip this step as far as I'm concerned, but I'm going to show it. What this ends up being is 5a minus 4b from the first set of parentheses minus, here's the mistake a lot of people make, they would do this. Well, if I have it looking like this, then only the 6a is going to get the negative sign, but it's actually both. So there's my rewrite. What it actually, and here's the step where most everybody should really go, is rewrite this as a 6a minus 6a and a minus 6b. And then the denominator just keeps tagging along. Now I want to also point out something else from the beginning. Notice I didn't even talk about reducing. I could have, but anytime you are given common denominators, just be thankful and combine the like terms, and if it reduces afterwards, we look at. Phrase my dad always used to say, never look a gift horse in the mouth. Look up the saying if you want to see it yourself. It's a good saying, but somebody gives you something, just be thankful, move on. All right, we were given common denominators, there they are. So now we are going to combine like terms. Well, I see A's, that makes a negative A. And I see B's, which together are going to make a negative 10B. Now this is a correct answer. We can't cancel this B with this B because they're part of a bigger thing. This B up at the top is connected to the minus A, so we can't do that, and nor with the A. And we can't reduce the 10 and the 12 because it's for the same reason. The 10 is attached to something. So this is actually all that we can do. This would be our answer. But I do want to discuss this. Other ways we could see this written. Since our numerator has both negative numbers, you actually could factor out a negative and write it like this. That would change both of their signs. The negative sign sitting out in front, and then we have 12 AB, because the order of the letters doesn't matter. This negative sign could be up here with the parentheses around the 10B and the A, a lot of things, a lot of different ways we could write this. But just keep in mind multiple representations, sometimes you have that. Okay. So our excluded value here is actually 0. We have to make sure that our denominator does not become 0, because that's the only rule it has. You can divide by fractions, negative, positives. You cannot divide by 0. Now I'm wasting a little bit of time, but just for your benefit, we have to solve for u to see what we have to avoid. Now the cube root of 0 is 0. The reason why I said I wasted some time here is because there is no plus or minus signs with the variable, which means it's all multiplication, division, or roots. So there won't be anything we can do there. So we've got our restriction on our domain here, and all we need to know is that the u value cannot be 0. So we got another subtraction, and we've got common denominators. There's our gift. We're just going to come over here and write this common denominator there. I am going to skip the step that I mentioned to you earlier. I have u plus v minus 3u. I am going to put parentheses though, just to remind myself. And minus v. You can show this work by showing the distribution of a negative term. So we got some stuff happening in the top. We do have common terms. The v's are going to cancel. Our u's are going to become negative 2u over 25u cubed. Okay, that is not the complete answer. That is not a wrong answer. It's just an unsimplified version. Now, I need to make sure nothing does reduce. In this case, we actually do have stuff that reduces. The u is in the numerator and the denominator. There's no separation with plus or minus sign, so that is just a reduction, excuse me. And the coefficients don't reduce. They don't have a common factor. So this would be our answer. If you ever have a question on your accuracy, here's another way you can check your answer as well. If I were to take y equals, y1 equals, and type in all of this I see here, I got a problem with the v's. You would have to substitute a number in for v. I would choose the number 3. Just arbitrary, pick a number 3. and you plug this in, and they should actually look exactly the same. Your table should be exactly the same. Okay, we got another subtraction. Notice the denominator could factor, but the factor is not going to help me because the first step is to get a common denominator. So I already have that, so why would I mess with it? So the first thing I'm going to do is I'm going to just come over here and rewrite my common denominator. If you wanted to write it in a factored form, you could, but I don't want too much going on at one time, so I'm just going to do that for now. Like I said, with the numerator, I'm perfectly fine with, and you notice I'm not putting the x plus 5 in parentheses because it doesn't have a negative sign. Had there been a negative in the very front here, that would be a consideration, but there wasn't. Now, the negative sign is going to change my x to a negative x, and it's going to change my 3 to a negative 3. So I'm going to combine my like terms. I see the x's are going to eliminate one another. And my 5 minus 3 is 2. All right, I have forgotten something, but it's okay because I have not canceled the denominator. I need to keep in mind that my denominator cannot be equal to 0. So I am going to write this in factored form. The factors of 6 and 12, well, 6 goes into both, and they both have an x. So the factored form is really going to benefit me on this one because I have two values I have to set equal to 0. Because if either of these do become 0, then the whole equation is lost. So I'm going to go ahead and write my excluded values, my restrictions on the domain. We need to recognize that x cannot be 0 because of this first half here. That would make it 0. And then x cannot be negative 2. These are not solutions, these are restrictions on the domain, which means we can't even use them. Let's write this factored form again, 6x, x plus 2. So we actually can reduce. Notice 2 and 6 do share a factor of 2. So I'm going to reduce this by 2, which makes my numerator 1. Remember, you never factor down to 0. So this is what we've got. So if I don't see this answer, what you probably have is an unfactored form, which would be 1 over x squared plus 2x, because the distribution of the x changes it to x squared plus 2x. Either of these answers are correct, either one is acceptable. That one's really just a personal preference on who's looking at it and what they want to see. If you wanted to take your excluded values right now, you could. Well, 20x to the third, well, that's x cannot be 0. And then the x minus 1, x cannot be 1. So those are our restrictions on our domain. Can't even use those. Now we have a common denominator. As funny as this one looks, it is a common denominator because they're exactly the same. Keep in mind as you do these, the order that they're in doesn't matter either. Just as long as everything is accounted for and everything is there. So we have that. This x plus 5 here does not need to be put in parentheses. Really, this one doesn't either because we have a plus sign, but it does not hurt. My concern would be some of you might turn this into multiplication. we finally have a plus sign right there. So what we end up having, let's just do this for habit's sake. Let's put this in parentheses. So we end up with x plus 5 plus x minus 2. Now the print, like we just said, the plus sign is serving no purpose. So I'm just going to drop it. Or I'm technically attaching it to the x, but okay. We're going to combine our like terms. The x's do not cancel. They become 2x. The 5 minus 2 is 3. And then our denominator goes untouched. Now we should get in a habit of looking to see, well, does anything factor? No. Here's a really good question. Does the 2 cancel with the 2? So hopefully you're saying no at this point. And the reason why it's a no is because of the numerator. The 2 is attached to something else, which means it does not reduce, or it could reduce, but it'd have to reduce from the 2 and the 3, which we don't have here. So that is just simply our answer. With excluded values or restrictions on the domain of using the number 0 and the number 1. Again, this one looks intimidating, but it's really no big deal. You could factor these to see if they cancel, but if they didn't cancel both sides, you actually made the question tougher because we have a common denominator. If you want to just go ahead and factor, you notice they're all even numbers. If you wanted to factor the 2 while you rewrite this, you could, just so you can kind of see what's coming. There you go. Now watch how we write the numerator. V plus 6 plus, if you want to put parentheses, you can, V plus 5. Ends up being 2V plus 11 over 2. Now let's look at that, by the way. Let's see if we can kill 2 birds with 1 stone. Is there factors of 5 that can become 6? In other words, what I'm asking, can we factor this term? We absolutely could. -1 and -5 add up to be -6, and they multiply to be -5. So we could write this as V minus 5, V minus 1. Now nothing here is going to cancel. We can't factor anything out of these 2. So we are just done. Now I'm not sure how you're going to see this answer. This is a really good looking answer. I like it. But you also could have it written in the standard form, which is to put the stuff back together. You could go way back to this, which is to distribute that binomial on the bottom. That's right, 100% correct. Or you could step all the way back to the very beginning since we didn't cancel anything. And it's 2v squared minus 12 plus v plus 10. Anybody recognizing what I forgot at the very beginning? Not a horrible crime because we have not passed this, but we didn't cancel anything. But remember, we need restrictions on the domain. So the restriction, I already had it factored over here. That's nice. The restriction for v minus 1 is we cannot use 1. And on the second one, v is equal to, v minus 5, so this would be v equal to 5, which means we cannot use 5 as a solution either, or as input value. We're not asked to solve here. All right, last one. Tried to pick one that looks bad, but really it's not. Let me show you one reason I picked this one. One, I wanted to scare you a little bit, but don't be. This one already has a common denominator. And like I said, don't mess with a good thing. Here's what some people are going to do, and you could totally do this, but it's actually going to make the question worse. This happens in rationals from time to time. We're in such a habit of reducing being a good thing, but if you look on the left side, do you notice what I'm seeing? I see an 5m plus 1 on both sides. Well, I could cancel this. You actually could. The whole thing cancels right there. Notice the problem, though? Remember our first step that we wanted to get done on a rational is to get a common denominator. Well, I've just stepped away from. I had a common denominator, now I'm stepping away from it. So I definitely don't want to do that. I want to keep my common denominator. I'm going to rewrite my common denominator. There it is. Now, my numerator, if this was a negative sign, it's very important that you put parentheses. A plus sign, it really doesn't matter. So here we have this. And some people are probably thinking, now we can cancel this 5m plus 1. That's actually not the case. Because now the 5n plus 1 is attached to two new things. So you cannot cancel here. The 5n plus 1 just became part of a bigger thing, so we're just out of luck. It's lost. Like a deck of cards. We shuffled them up, so you ain't finding that one again. If it comes back out at the top, we'll look at it. But before we go any further, we have excluded our restrictions on the domain. We need to make sure that the 5m squared does not equal 0. We need to make sure that the 5m plus 1 does not equal 0. And we need to make sure the 5m plus 4 does not end up equaling 0. First one's easy. No plus or minus signs. M can't be 0. Probably the most common one you're going to see when you do rationals. Second one, we're going to subtract the 1 over and then divide by 5, which tells us the m value cannot be value negative 1/5. And then lastly, we subtract the 4. M cannot be negative 4. You always want to take that restriction before you start canceling anything. Nothing is going to cancel here, I think. We're just going to put like terms together. 5m and m makes 6m. And 1 minus 2 is negative 1. I am not seeing anything that will cancel. So this should be all we have. You may not see this answer because you're supposed to distribute these. I'm going to do this just real quick so that you can, I wrote an X there, so that you can get a quick review. You can slow it down and watch it. But remember, we're going to distribute these terms. So the middle ends up being this. And then you would have to distribute still by 5m squared. So your denominator could be written as 25m to the fourth plus 105 m cubed plus 20m squared. I imagine the denominator is going to be left like you see it here, but that is also a potential answer right there. Okay, next step is going to be to combine rational expressions that do not have a common denominator. It's a major step up, but we've got to be able to handle this. Hopefully you did well with this. Always pay attention to those subtraction signs. They're the ones that will get you. Started with those, hopefully you can remember that. And then the way you combat making mistakes with these is just use parentheses. The parentheses will keep you from those mistakes. All right, good luck.